Hi everyone, and welcome back to another lecture on the solution to linear systems. Today we will talk three conditions that will give us unique solution, no solution, and infinitely many solution. So we are considering a 2x2 system. Let our system be a1x, that is a1x plus c1y equals to b1, and a2x plus c2y equals to b2. So we ask when it is possible that this system will have a unique solution. That is, if you have two straight lines, they will intersect at a single point. This is our unique solution. And from this point we will get x and y coordinates. This is only possible when, let me choose another color. So this is possible when a1 times c2 minus a2 times c1 is not equals to 0. I will justify why this is so. For no solution, we can have a1 b2 minus a2 b1. This is the condition that we are assuming first, and if this is the case, then the no solution will be given by a1 c2 minus a2 c1 equals to 0. So we are assuming this is true, and if this is true, only then this one will give me the no solution condition. Alright. Now let's talk about the infinite number of solutions. This is possible when a1 b2 minus a2 b1 equals to 0, and remember we are using and here, not or. a1 c2 minus a2 c1 equals to 0. This gives us the condition for infinitely many solution, and this is the geometrical picture of the unique solution, this one. Let's try to see the geometrical picture of no solution. So in the no solution picture, for our case, there is one line and there is another line. Let's say this is corresponds to equation 1, and this corresponds to equation 2. So these are like parallel lines, so they never met, hence no unique solution. And the case where we have infinitely many solution is that if this is the line corresponds to equation 1 and the other line corresponds to equation 2 and they overlap. Excuse my drawing, but they actually overlap. So this is the geometrical picture of infinite number of solutions. That is, at each and every point there is a solution. Now let's talk about how we can easily solve system of linear equations. And there are many methods. You can use row reduction formulas, but we won't be focusing on row reductions here. We want to solve for n cross n system. That is, the number of variables and the number of equations are same, and in general in the matrix form we can write it like this. And the method we are going to use is called Cramer's rule. And let's say your A matrix, that is your coefficient matrix, it has, let's say 1, 2, 3, then we can have 2, 3, 1, and then we can have 1, 2, 2. Our column vector x is like x1, x2, x3. So these are the unknowns we want to find out. And B is given by 1, 1 and 1. That is like this. So now we want to use the Cramer's rule. Cramer's rule tells us that if you want to find the variable xj, first you need to calculate the determinant of A, that is your coefficient matrix, and then let's say this is the jth variable, right, xj, and for our case, let's say I want to solve for x2. So instead of j, that is, I want to do it for j equals to 2. So let's write 2 over here. I have to evaluate the following. Now what does this A2 mean? A2 means is that instead of having this column, you replace it with the B. That is, when you are solving for the jth variable, you have to replace the jth column with the B column. That is the coefficients that are appearing on the right hand side of the system, or let's say just you have to replace the jth column with the B column. That's it. So if I replace that and I denote it with A2, so our A2 is 1 2 1 1 1 1 3 1 2. And if I want to calculate the determinant of A2, determinant of A2 equals to 1 times 2 minus 1 minus 1 4 minus 1, and the last part is 3 into 2 minus 1, and this will give me, let me close that, why it is not closing, oh, there it is. So we have 1 minus 3, and then we have plus 3. So this is just 1, right? Alright. So this is the determinant of A2, and if you evaluate determinant of A, this also gives you determinant of A equals to 1. So you can say x2 equals to 1. Similarly, you can solve for x1 and x3 using this formula. So let me clear everything out and state the punchline of today. So we were using Cramer's rule for solving linear systems, and if our system is like this, where this is, let's say, an n cross n matrix, this is a n cross 1 column vector or column matrix, and this is also a n cross 1 column matrix. For this type of system, the solution for any variable j, where j runs from 1 to n, this will be given by determinant of aj, that is the replaced column matrix, and divided by determinant of a. And this will be it for today. I will see you guys.